Welcome at RP Photonics. Have you ever dreamt that you could look into the inner workings of your laser or amplifier? That would surely make your R&D work far more efficient. Well, here I will show you how to realize that dream with computer simulations. You know, R&D teams struggle with difficult challenges. They need to go through multiple cycles of building, testing, error analysis, and design refinement. As you cannot look into your laser, you're effectively fishing in the dark. That makes it difficult to accurately diagnose issues. Also, it is often hard to anticipate side effects of design changes. Not surprisingly, this often takes long and results in high cost. Consider not only the parts, but also the salaries of a whole team of engineers month by month. The core issue is really that sophisticated physics determine the working of your laser or amplifier, and it takes time to find out how to get it working. Now I show you that and how this challenge can be met more efficiently by producing key insights with simulations of the laser or amplifier operation on a computer. I am Dr. Rüdiger Paschotta, in short RP, the founder and managing director of RP Photonics. In my earlier career as a researcher, as well as later as a technical consultant, I was often facing the same kind of challenges as you do in developing laser devices. Simulations were in many cases a crucial factor for the success of my work. Nowadays, I concentrate more on developing professional simulation tools and helping both scientific researchers and laser engineers to successfully use them for their work. Let us consider how development works in practice. What is inevitable is that we go through some cycles of testing and refining a design. We generally cannot expect to arrive at the final solution directly. Let's see how one development cycle looks in a typical case without and with using a laser simulator. First, your prototype will consist of some parts, so you need to find suitable suppliers, order the parts, and wait for them to arrive. When working with a simulator, this step is completely eliminated. Second, test the prototype. In the lab, you assemble the parts, set up all the required diagnostic instruments, and do your measurements. That will take days or weeks. With a simulator, you configure the simulation model and the wanted diagrams, then execute the simulation. All that you can do within minutes. Third, analyze any problems. In the lab, you do various measurements, discover problems, then speculate on possible reasons based on the limited available information. Finally, you form an opinion on the suspected cause. With a simulator, you easily analyze the situation, for example, by inspecting the diagrams for different input power settings. Within minutes to at most a few hours, you get complete clarity on what caused the device to malfunction. Finally, refine the design of the device or system based on the obtained insight. That step is the same for both approaches, except that of course it works better with clear insight from a simulation. So, quite obviously, the efficiency and also the creativity of your development work can greatly benefit from utilizing simulations. Of course, if simulation requires too hard work, it might not be worthwhile to do. But how much is it really? That very much depends on how simulations are realized. Developing a simulation tool certainly means a huge investment of time by somebody who is highly competent in laser physics, numerical algorithms, and software programming. Note that it should also be thoroughly tested, well usable, and flexible enough to be applied to many cases. Using an existing simulation tool is far easier, especially if it is well engineered. You then don't need to deal with the details of laser physics, algorithms, and making a user interface. Rather, you simply interact with some nice tool which allows you to fully concentrate on your purpose, which is understanding your lasers and making progress on them. And this holds regardless whether you are a researcher or a laser engineer. Also consider that as a user of a professional simulation tool, you can expect to get competent technical support. At RP Photonics, that goes even far beyond purely software-specific issues. But what if you need simulations only for a short while? Maybe a more efficient solution is then to get someone else to do the simulations for you. We also offer that. Let me quickly summarize what you learned in this video. It is easy to imagine what a profound impact working with computer simulations can have on your development work. The savings in time and expenses can obviously be huge. Consider also the quality of the resulting design. That will normally be higher for a simulation-based process due to the far deeper insight obtained. Also, that way you learn far more and rapidly improve your competence and creativity. For these reasons, start utilizing simulations for your work, no matter whether it is industrial laser development or scientific research. RP Photonics has excellent simulation software tools and also gives very helpful technical support. We are particularly strong concerning fiber amplifiers and lasers, but also for things like bulk laser resonators, multi-layer coatings, and ultra-short pulse propagation. By harnessing the power of cutting-edge simulation tools, you'll be able to excel in your work. You are welcome to explore our offers on our website and contact us if you have any questions or concerns.